Two people can share 99.9% of their DNA and still have completely different coloured eyes. That tiny 0.1% decides whether you inherit the most common eye colour on Earth, or one so rare geneticists still argue about how it happens. Eye colour isn't decided by one gene, the way your old biology textbook probably told you. It's a combination of at least 8 different genes, working together, competing with each other, and occasionally producing something completely unexpected. Today, we're breaking down every eye colour humans have, the actual biological causes behind them, and the historical figures whose eyes shaped legend, war, and myth. Brown. Let's start with the baseline. Brown eyes. 70 to 80% of the world's population has them. The main gene responsible is called OCA2. It controls how much melanin your body produces and deposits into the iris. Brown eyes simply mean a lot of melanin sitting in the front layer called the stroma. More melanin, more light absorbed, darker colour. It's genetically dominant, which is part of why it's so common worldwide. Julius Caesar is one anchor here. Bust reconstructions and ancient accounts point to brown eyes, consistent with Mediterranean populations of the time. We can also look at Cleopatra. Ptolemaic ruler, Macedonian Greek ancestry, though heavily debated by historians. Most reconstructions and coin engravings suggest dark, likely brown eyes, consistent with the Eastern Mediterranean gene pool she descended from. And a stronger case, because contemporary accounts actually survive, Anne Boleyn, a Venetian diplomat who saw her in person, described her eyes as, quote, black and beautiful. Most historians read this as very dark brown rather than literally black, since true black eyes are essentially non-existent in humans. Quick honesty check before we move on. No DNA sample exists for Caesar or Cleopatra. This is inference from portraiture and historical record, not confirmed genetics. Boleyn's case is stronger since it comes from a direct eyewitness account. Blue. Now, blue eyes. 8 to 10% of people globally. And here's the part that surprises most people. Blue eyes trace back to a single mutation in a gene called HERC2, which sits right next to OCA2 on chromosome 15. This mutation doesn't destroy the OCA2 gene, it switches it off. Less melanin gets produced in the iris at all. That mutation happened once, near the Black Sea, somewhere between 6,000 and 10,000 years ago. Every blue-eyed person alive today shares that one distant ancestor. It's one of the clearest examples of a single founder mutation spreading across an entire species. Here's the twist though. There is no blue pigment in a blue eye. It's an optical illusion. With so little melanin, light entering the iris scatters instead of being absorbed. The exact same physics, called Rayleigh scattering, that makes the sky blue. Our historical anchor? Alfred the Great. Anglo-Saxon populations carried a high frequency of this mutation, consistent with descriptions from the period. A second, more legendary case, Genghis Khan. The Secret History of the Mongols describes members of his lineage with pale, cat-like eyes, sometimes translated as blue-grey or green-grey. This is one of the oldest recorded eye colour descriptions in Central Asian history, but it comes from an epic chronicle written after his life, not a verified eyewitness account, so treat it as legend rather than fact. Green. Green eyes are the rarest of the common colours, just 2% of people worldwide. This one isn't a single gene, and it isn't simply a mutation like blue. Green happens when you get a moderate, in-between amount of melanin from OCA2, combined with a separate yellowish pigment called lipochrome, layered over that same light scattering effect we saw with blue. Blue scattered light plus yellow pigment optically blends into green. Because it depends on this specific combination landing together, it's genetically harder to predict than blue or brown. You'll find the highest concentration in Ireland and Scotland, and pockets of unusually high frequency in Central Asia, particularly Afghanistan and Pakistan. For a modern icon, most people immediately think of the 1985 National Geographic photograph known as Afghan Girl, Sharbat Gula, whose green eyes became one of the most recognised images of the 20th century. For a historical case, we can actually turn to Vlad the Impaler. A papal envoy named Nicholas of Madrusa met him in person and left a physical description. Wide open eyes framed by black eyebrows. Most English translations render the eye colour as green, but the original Latin word he used, glaucos, is disputed by historians and translates closer to blue-grey. It's a rare case where we have a genuine eyewitness description, and scholars still can't agree what colour it's actually describing. Hazel. Hazel eyes, about 5% of people. This is genetically the most unstable looking colour, and it comes down to uneven melanin distribution. Instead of melanin spreading evenly across the iris, hazel eyes have it concentrated unevenly, often more at the edges. Combined with lipochrome, this creates an eye that can shift, appearing brown near the pupil, green near the rim, sometimes gold in direct sunlight. It's the colour most affected by lighting conditions, and even the colours you're wearing, because the base pigment mix is so close to the tipping point between categories. A useful myth bust here from the modern era. David Bowie's famous two-toned eyes were not two different eye colours at all. As a teenager, he was punched during a fight with a friend, which left him with a permanently dilated pupil, a condition called anisocoria. Both eyes are actually the same base colour. It's the pupil, not the iris pigment, creating the illusion. Historically, hazel is genuinely difficult to trace. Multiple monarchs and courtiers have been described with shifting or changeable eye colour over the centuries, but pigment fading in old paint and the vague colour language of the era make these claims largely unverifiable. Amber. Amber eyes are genuinely rare. The cause here is almost the reverse of blue eyes. Amber comes from a high concentration of lipochrome, that same yellowish pigment we saw contributing to green and hazel, but this time with almost no melanin at all in the stroma. The result is a solid gold, copper or coppery orange tone, sometimes with a slight greenish tint near the pupil. People often confuse amber with hazel, but amber tends to be far more uniform and solid in tone, without the multicolour shifting. Historically, amber is one of the hardest colours to trace to specific verified figures, since most written accounts before the modern era used amber, gold, and yellow-brown almost interchangeably with hazel. You'll find wolf eyes mythology tied to this colour across multiple cultures, from Slavic folklore to parts of East Asia. Worth saying, clearly on screen, that's folklore, not genetics, and no verified historical figure is confidently documented with amber eyes specifically. Grey. And finally, the rarest of them all, grey eyes, under 1% of the global population. Grey works through a mechanism very close to blue, extremely low melanin in the stroma, but the difference comes down to collagen density in the iris itself. Denser collagen fibres scatter light at a slightly different wavelength than the sparser collagen in blue eyes, producing a grey or steel tone instead of blue. This mechanism is still an active area of study, so treat it as the leading theory rather than settled fact. Grey eyes are most common in Eastern Europe and parts of Northern Europe, particularly around the Baltic states. Norse sagas frequently describe unusual, piercing eyes in figures like Sigurd Snake-in-the-Eye. It's a strong connection to explore, and one you've already covered on this channel. As with all saga-era descriptions, this comes from literary tradition passed down over centuries, not a contemporary eyewitness account, so it belongs in the legend category, alongside the Genghis Khan description from earlier. So there you have it, 6 colours, at least 8 genes working together, with OCA2 and HERC2 doing most of the heavy lifting, and a handful of others fine-tuning the final result. From Caesar's Rome to a Venetian diplomat's eyewitness account of Anne Boleyn, to a mistranslated Latin word that's kept historians arguing about Vlad the Impaler for centuries. Eye colour has shaped how we describe power, mystery and identity for thousands of years, even when the actual science behind it wasn't understood until the last few decades.